Welcome to Eeci GATE's Electrical Gate 22 solutions. Next problem, problem number 31 as per the master paper based on circuits transients. That's a very simple, interesting problem. So given in the circuit shown below, the switch S is closed at time t equal to 0. The magnitude of the steady state voltage in volts across the 6 ohm resistor is up to 2 decimal places. Okay. So the switch is closed at time t equal to 0. So that means initially the capacitor is remaining uncharged. That's how we can feel. Okay, so after making the circuit connections, the battery is not exiting the circuit and the battery is coming into play only after a t greater than 0. Okay, so now let us play with the given figure. So assume the switch is closed. Assume VC of 0 minus is equal to 0 volt. There is no voltage across capacitor. The switch is closed at time t equal to 0, t greater than or equal to 0 second. It remains closed forever till time t equal to infinity. So it is the analysis only at steady state means you can set the problem only at time t equal to infinity because t equal to infinity is the final steady state point. That means you allow infinite time for the circuit to reach steady state and then you are doing the analysis at steady state. That's what it means. Okay, so let me take this as a reference. This is 0 volt. Therefore, this point is going to be 10 volt. Okay, yes. So this is also going to be 0. This is also going to be 0. So that means there will be a current in this direction. So there will be a current. Okay, there will be a current in this way. There will be a current in this way. And let me call this current as I1, this current as I2. And I1 at time t equal to infinity will become 0. I1 at time t equal to will become infinity. Sorry, I1 at time t equal to infinity will become 0. Reason is that the capacitor is going to be fully charged at time t equal to infinity, but we don't know that potential, so not required as well. VC of infinity is attained a finite value that is enough to make its current 0 at steady state. Okay, so then this current is made 0 at steady state means then what happens to the circuit? The remaining circuit is coming into the play. So what is the remaining circuit? So this 10 ohm and capacitor is not coming into play at steady state. Therefore, the 6 ohm, 3 ohm and this 2 ohm alone is coming into the play during steady state. So what we need to find out? We need to find out the value of the voltage across the 6 ohm resistor. Okay, yes, we'll go for that. So then the equivalent circuit is going to be this. So we have a 6 ohm resistor. We have a 3 ohm resistor. Here, the capacitor circuit, overall circuit resembling an open circuit because there is no current in that path. And here we have a 10 volt battery. And then we have a resistance, series resistance. The resistance was given, that is 2 ohms. Yes, that's all. So we are looking for voltage across 6 ohm resistor. Okay. So already current direction given, that is how it is going to exist. Therefore, we will take this as positive and this is negative. That's a potential we want to determine Vx, voltage across 6 ohm resistor. So now 6 and 3 are in parallel. That is going to be effectively in series with the 2 ohm. Therefore, the net resistance seen by the battery, let me call it as net resistance seen by the battery as R total. So R total is equal to the 2 ohm plus 6 ohm parallel 3 ohm. So that is going to be R total is equal to, it is 2 plus 6 parallel 3 also 2. If you already practiced enough, you know that number. You don't need to waste time for this manipulation. So then believe it, R total is equal to, or if you try 6 into 3 by 6 plus 3 also, you will end up with that. It's 18 by 9. So it's going to be 2. Okay. So R total will be 4 ohms. Then the current will be 10 volt exciting the circuit. Then current will be, total current will be I is equal to 10 volt divided by 4 ohm will be the current supplied. That's going to be 2.5 amp. Okay. So that's a current coming from the supply. So 2.5 amps. Then what, assuming this is a reference of 0 volt, then how much you're going to lose from 2.5? You're going to lose, sorry, 2.5 into 2, you're going to lose 5 volts. So then this is the 10 volt. So from 10, you are losing how much? 5 volt. This point is going to be 5. Therefore, this also going to be 5. So given already the reference of 0, therefore answer is Vx is equal to potential marking is correct as per the current direction. So the right side is higher potential, left side is lower potential. That's confirmed. So it's 5 minus 0. That's your Vx. Or you can also say the total circuit resistance is going to be 2 and 2. Because of this, it is 2. So therefore, the voltage will be equally divided between the 2 and 2 means then 10 volt off of the 10 volt is going to be 5. Straight away we can say the voltage Vx is equal to 5 volt. Okay, so there is nothing there to play in transient because the transient circuit is given actually, but problem is set in steady state. So that means all the transients are already died out at steady state and the capacitor branch is not coming into play. That current is 0 is the key to get the answer instantly. That's how this problem has to be approached. Okay, so that's one of the interesting problems from electrical gate 22 paper. Okay, and hope you enjoyed this content. We'll update you with the next video, so you can subscribe and then you will get the updates instantly. Okay, yes, thanks for watching.